So you just finished part one video. So here's the second part. The second part's going to be more focused on z-score. We kind of covered that a little bit in the last video, but here we're going to talk a little bit more about what a z-score is, how to apply it to some example situations. So a z-score will show how many standard deviations a value lies from the mean. That's where you have x is equal to your value, that mu is equal to a mean, and then that little sigma down there, so right here in this location, that's a sigma, that's a standard deviation. So just to let you know this, I'm calling this a mu, I'm calling this a data point, or a value, or a test statistic, and then I'll be calling this a sigma. Those are just, it's not what they are, it's just what that symbol is called. So in reality, this is just an X, but for the sake of this part of the video, I'll be trying to just use the words value, mean, and standard deviation. So we're going to look at the first problem. And example 1 is telling us that the grades on a statistic midterm are normally distributed with a mean of 81 and a standard deviation of 5. Find the z-scores for each of the following. Now, we don't need to draw the bell curve here. It's okay for us because we know what the bell curve looks like. We know it's a normal distribution, so we know it's going to look something like that. Now, we do have the mean, so the mean is the mu, and that mu is equal to 81. We also have the standard deviation, which is this sigma, and that standard deviation is 5. So what we're going to do, we're going to use our formula. I'm going to write it down here in the bottom, where we have z is equal to x minus mu over the sigma. Now, x is the data points. So that we have 3 data points. We have A, B, and C, where it says 65, 83, and 100. So that means that they hopefully got a perfect score, 100. That's great. And that's what we should be getting on this project. So I'm going to take my data point 65, and I'm going to subtract that from my mean of 81, and then divide that by 5. Now, if you put in your calculator, and I'm just going to apologize right now, my calculator is not working on my laptop due to technical difficulties. So if you did on your calculator 65 minus 81 over 5, it'll give you some number like 48.8. That is not the way to put it into the calculator. When we're trying to put numbers in the calculator, make sure you put a parentheses. 65 minus 81 slash, and that's that divided sign 5. And the reason I'm writing it out is because you can't see what I'm typing into the calculator. So that's what I'm typing into the calculator. When you do that, you'll find that your z-score is going to be equal to negative 3.2. So if I'm looking at example B, just to explain what this negative 3.2 means, it means I'm negative 3.2 standard deviations away from the mean. So that would mean that I'm in the 99 percentile range. I'm somewhere around 99 percentile range. Now, sadly, this is in the bad version because it's a 65 and we don't like Fs, which is the grade we're not getting on this project. So we're going to have a Z. Now looking at this B problem, I'm going to take my data point of 83, subtract that from my mean of 81, and divide that by 5. When I plug that into the calculator, it's going to look something like this, 83 minus 81 over 5. When I do that, I'm going to get the value of 0.3, and I'm just writing 0.3. You don't have to. You can write 0.3. I just know it's either or. They're both equal to the same thing. And then let's go to this last one. We're going to look at the data point of 100, subtract that from the mean of 81, and then divide that by 5. I'm not going to write it out. I think you kind of get my point. And that will give us a standard z-score of 3.8, which will give us a great, it's again the positive in the 99 percentile, where it's the positive 3.8 standard deviations above. So now on to number 2. This, since I don't have my calculator, it's saying that we have a set of data that represents the height of the basketball players at Greenwood High. Well, what we need to do, we need to put this set of data into your calculator. So what you're going to do, you're going to hit Stat, Edit, and then in your L1 list, I want you to input all of those data. Now, if you have data points already in it, go all the way up to L1 until the black box is over L1, hit clear. That should clear all those data points so that you'll be able to put in 76, 66, 67, 69, 73, 74, 72, 71, 75, 69, 72, 70, 78, 70, 71, and 73. I've just put those into my calculator as I'm talking. Hopefully you did too. If not, pause the video until you get your data points entered. Alright, I'm glad you're back. And so what we're going to do is we're going to hit Stat again. So this was for the data points entry. So now we're going to hit Stat. And this time you're going to move over to Calc. And after you hit Calc, you're going to hit that one var stats. And what that basically is, it's going to give us a lot of different statistic points on our thing. Now, if you hit enter immediately, again, just a reminder, that's going to go straight to L1. If you don't have your data points in L1, you'll need to put your either L1, L2, whatever column that is in. And you can do that by hitting second and the number on which that column is located at. When you hit enter, you're going to have all these things. You're going to have something like an X bar, you'll have something that a little sigma X, you'll have a little sigma X square, you're going to have this SX, or that looks like an E really, and then you're going to have this X and then an N. Now for me, I see this, and hopefully you do too. I see X bar is equal to 71.625, and I'm just going to enter the ones that are important to me. 9, 8, and then it goes on forever. So these three right now, we don't really have to worry about. We're just going to focus on these three. What this X bar represents, this is also known as our mean. It's just a different way to show it. And the way, so the mean, just remind it's that mu. This sigma X is also the, that's our standard deviation. So just a reminder, this is going to be our standard deviation. Here's our mean. And N, that's just the number of data points we had. So if it's not 16, that means you might have missed one. So that's okay. Now, what we're going to do, we found our mu. Our mu is going to be equal to that 71.65. But what, for my sake, I just want us to do rounding. Keep the whole numbers, make it less complicated. So I'm going to make my mu 72, and then my sigma, I'm going to round down to 3. So looking at A, I'm going to use a different color of this. Looking at A, we're going to use our formula of Z is equal to mu minus, or not mu, I'm sorry. Z is equal to X, which is our data point, minus mu over sigma, which is our standard deviation. So we're going to have a 66 minus a 72 over 3, and that's going to be our Z-score for A. Well, when I do that, just a reminder, you're taking the parentheses 66 minus 70. This is what you would type in into your calculator. You're taking that Z, and you'll put that in, and you'll find that you will get negative 2 as our data point. So when I do 66 minus 72, divide that by 3, you should get negative 2. So we're two standard deviations away from the mean. So that means this person would be shorter if it's away that way. So it's 66 inches, so 5'4". Well, let's look at this next one. This next one, we're going to have our statistic, our data point, 73. Subtract that from 72. Divide that by 3. And you'll see that this is going to be 0.3 repeating. Well, rather than writing 0.3 repeating for the sake of today, I would just like you to round to 1 decimal point. So we're going to round this to 0.3. And again, you can do 0.3 or 0.3. Either way, it doesn't matter. I'm going to write a 0 there just so that you can tell that this is only 0.3. And then this last one, we're going to do our data point at 80. Subtract that from 80. Or not from 80. We're subtracting that from 72. And when we subtract that from 72 and divide that by 3, we're going to get 80 minus 72 divided by 3. You'll get a 2.6 repeating. You just round that up to 2.7, which means that we are 2.7 standard deviations away. So, looking at number 3, I've already found the mean. That's the x bar. And, well, that might not be right. So, to double check, I'm going to give you some time to put it in. So, reminder, hit stat edit, go up to that L1, clear it out, get rid of all those data points. And after you clear it out, let's go put in the data points. So, to clear it, you go to L1 again, hit clear, then enter. After you do that, edit. Okay, there we go. Let's put in the data points. So we got 48, 100, 92, 100, 92, 92, 84, 68, 84, 92, 52, 56, 88, 62, 58, 80, 84, 44, 88, 80, 68, 96, 88, 72, and 80, which leaves us with 25 data points. Oh my goodness, that's a lot of people. That's a class size, that's bigger than our class. So what we're going to do, we're going to hit stat. Again, go over to calc and go to that one var stats again and hit enter. Just a reminder, if you chose to not put in L1 and did it in another, you're going to have to input that L2 or that L3, then hit enter, because it's automatically going to go to L1. So I'm going to just write to the side the different numbers that we had. So just the important ones. I'm going to write X bar, we got 77.92. I got for my standard deviation of X, I got 16.25, 280, blah, 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 blah. And then I got n is 25. Again, the n doesn't matter. I just write the n to make sure that you know how many data points that you put in. In case it's not 25, that means that you missed one. Or if it's over 25, you put in too many. So again, we're going to round. So we're going to round up where, sorry about that. We're going to round up where this 77.92 will be rounded up to 78. And then the sigma, we're going to round down to 16. Now, when we got this, let's go ahead and do our z-scores. So just a reminder what the formula is. We're doing z is equal to x minus mu over sigma. Now, when we do that, we will be having the, let's see, we got x minus mu over sigma. We're going to do our x, so 44, set this equal to z. 44 minus our mean, so 78, and then divide that by 16. When you do 44 minus 78 and divide that by 16, you'll get where it will be a negative 2.125. Just leave that as a negative 2.1. I'm fine with that. And so now going over to b, we got one z down, 2 to go. We're going to set z is equal to the 68 minus the 78 over the 16. Well, that z is going to be equal to negative, let's see, 68 minus 78 over 16. Uh-oh, new calendar. And that will be equal to negative 6.25. You can just leave it as negative 0.6. And I'll let you do this last one. I won't show the process, but I'll just give you the answer where the z is going to be equal to 1.1. For this last one, what we're doing is we're doing something a little different. We have the z-scores of 4 students on a particular algebra test that are given below. If the mean of the test is 85, so that's important to us, the mean of the test is 85, and the standard deviation was 4, find each student's test grade. So it's great with this formula. Just a reminder what the formula was. It's going to be z is equal to x minus the mean over the standard deviation. Given that average of 85, So I'm going to say my mu is 85 and the standard deviation of 4. What I can do is I can use this and look for my x, because right now we're looking for those data points or those values because we're given a z-score, we're given the mu, which is the mean, and we're given that standard deviation. So what we're going to do, low battery, let me plug up. It just take hopefully a couple seconds. As I'm plugging up, go ahead and think about how we can solve the first one. All right, I am all plugged back in and charging. So hopefully you did a little bit of thinking. If not, you were probably on your phone, which I understand. So here we want to do is let's look at Zach first. I'm gonna break this up. We got Zach. Break this up into 4 people. So here we got Zach, and you see that his z-score is equal to negative 0.75. So what we're going to do, we're going to take this negative 0.75. We're going to set that equal to x minus 85 over 4. And the reason is this, remember that mu is that mean, so we're plugging in 85. That standard deviation is the 4, so we're plugging that in. So I'm going to multiply both sides by 4. And when I multiply both sides by 4, I'm going to get a negative 3 on this side. So that's going to be multiplied by 4. Here will be multiplied by 4. So then I'm going to have negative 3 is equal to x minus 85. Well, we're not done yet. We got to get x by itself. So to get x by itself, I'm going to add 85 to both sides. And when I add 85 to both sides, I'll find that x is equal to 82. We're again just reminded what this x is equal to. 82 is representative of Zach's test. So Zach got an 82. Because it's negative, it means that he was below the mean. If it's positive, more than likely that's going to mean he's above the mean. So let's look at Taylor. So if we're looking at Taylor, Taylor got 3 standard deviations, or 3, her z-score was a 3. So do you think she's above or below? Well, she's above. 3 is going to be a big one. So let's look at 3 equal to x minus 85 over 4. We're going to multiply both sides by 4. 3 times 4 will give me a 12. And then I'm going to take that x minus 85 to add 85 on both sides. And when I add 85 on both sides, I'll find that x will be equal to 97. Good job, Taylor. Got an A plus. That was good. So now we got 2 more people. So now I'm going to look at Ross. And Ross, he got a negative 2.5. What do you think that's going to be for his score? That's right. He didn't do so hot on this test, and that's my prediction. We'll see how well he did. We're going to get this negative 2.5 and set that equal to x minus 85 over 4. Then we're going to multiply both sides by 4. When we multiply both sides by 4, I'm going to do 4 times negative 2.5, and that'll give me a negative 10, and then I'm going to add x equals 85. I'm going to add 85 to both sides, and x then is going to be equal to 75. Well, that's not terrible. It's still a C. It's still passing. So it's not as bad as I thought it was, which is good. So this last person we're going to look at Natalie. And when we're looking at Natalie, I'm going to let you do the work. I'll give you about a minute to do the work, and then I'll write what your score should have been. And again, I want to see work out on your paper so I can count this towards your project. Or me, Miss Allen, or Mr. Sorry can count it. All right. So hopefully you're done by now. If not, you can pause it. But I have it where the test score was a 90. She just made the cut with an A and got a 90. Way to go, Natalie. So that concludes this part of the video for the examples. You can now move on to your page 2 document where it says number 1, the scores from a statistics test were 99, 60, 82, 78, blah, blah, blah. And go ahead. If you have any questions, please ask your teacher. And go Dogs and go Spartans.